Welcome back to the podcast. You guys love olive oil just like I do. I'm a huge advocate of olive oil, and I love talking about some of the key compounds in olive oil, like oleocanthals, like hydroxytyrosols, these different polyphenols that are just so amazing for the body. And so I wanted to bring on an expert, Dr. Limor Goren, and she is the founder of Ph.D, which is an olive oil company. She is a cancer researcher with a Ph.D. in molecular biology. Her research centers on one of the most important anti-inflammatory molecules found in medicinal olive oil called oleocanthal. And oleocanthal is kind of what gives you the bitter taste. If you have a really good, really high quality olive oil, you kind of notice that bitter taste in the back, and that's credited to oleocanthal. And Dr. Goren discovered one of the mechanisms by which oleocanthal is toxic to cancer and showed that olive oils that are rich in oleocanthal are an effective strategy to kill various types of cancer cells. Dr. Goren started Ph.D after she received numerous requests from friends and family for the medicinal olive oil she used in her research and realized it was not easily accessible in the US. We'll talk more about that, how most of the olive oil out there is actually very low in polyphenols and really not getting the benefits from it. So Dr. Goren searched the world for the best high phenolic olive oil and ultimately came across a small family-owned farm and mill in Corfu, Greece, which I may have said that wrong. I'll have her clarify that when she gets on. Yeah. What was it, Dr. Goren?
It is Corfu.
Yeah. Corfu, Greece. Okay. Yeah. And that community had just won an award for having the highest concentration of oleocanthal ever discovered at that time. From here, Ph.D was born, and Dr. Goren's mission to advocate for the health benefits of olive oil took hold. It is her goal to spread awareness about the holistic approach to health and to make high phenolic olive oil accessible to consumers. So, Dr. Goren, welcome to the podcast.
Thank you so much. I'm so happy to be here and nerd together about my favorite subject that seems to be one of your favorite subjects. That's great.
For sure. Well, oleocanthal is an amazing compound. And so you obviously are an expert in it. So we want to talk about that. But how did you get started? How did you kind of go down this route of studying polyphenols?
It kind of fell into my lap or onto my bench in the lab. I was working in a cancer lab at Hunter University in New York City. And I was actually working on a different project that has to do with the mTOR pathway that some of your listeners might be familiar with. It's a pathway that regulates nutrient input and metabolism in our cells. So I was working on that pathway when this really interesting molecule was sent to us by a collaborator. It was recently discovered. It was isolated from Greek olive oil, and it was given the name oleocanthal. And he thought it might be an interesting molecule for us to study because in very early reports, it was shown that it does kill cancer cells pretty rapidly. And the suspicion was that it has something to do with the mTOR pathway. It still might have something to do with the mTOR pathway, but that's probably not the main function of it in the cells. But that's how I got involved with it.
That's interesting. And a lot of my audience is familiar with the mTOR pathway. Not everybody, but the mTOR pathway we've talked a lot about when it comes to fasting, because the mTOR pathway is associated with growth and cell reproduction, which is obviously important when we're a child, when we're growing, pregnant women, things like that. But as we get into older, as we become adults and we stop growing, we don't want to overactive mTOR pathway. There can be a lot of problems there. And so what did you find with your research? Let's start with just the mTOR pathway itself, and then we'll talk more about oleocanthal.
Sure. So our research on the mTOR pathway involved a very specific kind of feeder pathway into it. We tried to understand how via mTORs cells can sense nutrient sufficiency, especially of lipids. So because when mTOR functions properly, it gives signals to the cell. Do I have enough proteins for growth? Do I have enough sugar, glucose to growth? It senses all these things, but it was really unknown how the mTOR pathway in the cells sense lipid sufficiency, the idea that there's enough lipids. So we studied a pathway that we believed had to do with that, and it had to do with a phospholipase called phospholipase D that creates a metabolite called phosphatidic acid that was a strong activator of mTOR. And because of that, often when you talk about mTOR, obviously you can talk about longevity because it's associated with longevity, underactivation. But the flip side of that, mTOR is often very, very overactive in cancer. So we studied in the context of cancer and how some cancers hijack that signal from phosphatidic acid to mTOR and can bypass all the checks and balances and send growth signals to the cells. So this was a previous project. And Oleocanthal related to that, not directly, but in a very interesting way, because my research showed that Oleocanthal acts on a cellular organelle called lysosomes. And mTOR, if you know, mostly locates to the lysosome. So that was the connection, I would say.
Interesting. And phosphatidic acid as a driver of mTOR, is that part of our diet? Where is the mTOR getting that from? Is it part of our diet, or is it just something that's grabbing from cells, from cell lipids?
Yeah. So phosphatidic acid is a metabolite. It's a metabolite. It's a byproduct of lipid metabolism. So every time we eat dietary lipids, any kind of fat source, via various enzymatic reactions that culminate in phospholipase D, you can create phosphatidic acids. But cell usually divert which phospholipases they use depending on the circumstances and what they need. But yeah, fat comes from the diet.
That is a mechanism for how, because we know that higher insulin, high blood sugar, high insulin drives mTOR. We also know that high amount of amino acids, particularly branched chain amino acids like leucine, will drive mTOR.
Right.
I hadn't heard of a fat connection, but the phosphatidic acid would be the fat connection.
Exactly. That is the missing link, and that's still work that's in progress. We published quite a lot about it, but it's still, I would say, in the baby steps of the discovery of that pathway.
That's really good. And this is why keeping mTOR under control, which, are you familiar with a way, like, as a molecular biologist, how were you guys looking at the mTOR pathway? Were you just looking at it like under the microscope, or was there like any sort of lab test that can be done to help somebody understand if their mTOR pathway is overactive?
You look at downstream targets of mTOR. So mTOR is a type of enzyme that catalyzes a reaction. Let's keep it simple. Catalyze a reaction. You can look downstream to see if the reaction happened by looking at phosphorylation of its substrate proteins, especially ribosomal protein S6 kinase. So that's like a very good reading of that. So you can always check the status of that, whether it's phosphorylated or not.
And that's how you know if your mTOR is active or not. As a lab test. So you said, what was the molecule you mentioned?
S6 kinase.
S6 kinase. So that's
the letter
like enzyme.
S. Yeah. It's a kinase. So there's like a kinase cascade, I would say, in the cell that starts with mTOR, and then it phosphorylates S6 kinase, and that phosphorylates other target proteins. So you look at the most direct ones. I don't know if there is a test that is approved to use in humans. We were using it, both on, just like on cells or cells that were derived from animals that, we smashed and isolated. So I'm not sure if that's something that is available commercially. Great question.
Yeah, I haven't heard of it. I think that would be a really great discovery if somebody were to be able to find some sort of biomarker that we could just, whether it was a blood draw, most likely a blood draw, but, urine sample, whatever it was, that we could find that would let us know kind of the status for mTOR. That would be really interesting for the future.
That's an interesting question. I wonder if that exists. I know I'm going to check it out after our recording, because I'm intrigued now.
Let me know, because I haven't heard anybody actually say that. Everybody says, we're thinking cancer cells, based on, studies, molecular biology studies, we understand how mTOR, hyperactive mTOR drives cancer growth, but we're not actually looking at studying that, in humans to know, in a sense, right? What types of cancers are more mTOR driven, which ones aren't, things like that. So it'd be really interesting to be able to look at that.
This is known. This, when we send tumors out for biopsy, we can definitely look at the markers. Cool. You can see that in pathology of a tumor. But just, for like everyday maintenance health, just like you say, like a simple blood test, I'm not sure if that exists.
Yeah, that would be
Yeah,
really
and especially if
interesting.
somebody is really actively interested in inhibiting mTOR pathway, if you fast intermittently or fast
Yes.
or use other mTOR inhibitors, yeah, you want to know whether you're successful. That's an interesting point.
For sure. Yeah. My favorite ways to inhibit mTOR, I think fasting, intermittent fasting is probably the best strategy, but also exercise, regular exercise is important there. Good sleep, things like infrared sauna, and then getting a lot of polyphenols in our diet, keeping our blood sugar stable, eating a good balanced diet, and then, getting a lot of polyphenols like oleocanthal. So it takes us back
Mm-hmm.
to
Yeah.
oleocanthal, and you were studying how this impacts cancer. And so let's talk a little bit more about your research there.
Sure. So one slight correction to your introduction, and it's very nuanced,
Yeah.
but I think you'll find it interesting. So oleocanthal is not necessarily in charge of the bitter flavor of olive oil, but rather that stinging sensation we feel at the back of our throat that feels
Okay.
more like a pepperiness, like black pepper. And in fact, the name oleocanthal is derived from Latin, and in Latin, canth means sting. So it's the stinging ingredient in olive oil. Other polyphenols, such as oleacin, oleorubin, are more in charge of the bitter flavor that we feel at the front of our palate. So definitely bitter flavor in olive oil is desirable. That's an indicator that the olive oil has polyphenols. But not all olive oils have the same composition of polyphenols. So if you feel bitter, it's definitely high in polyphenols, but only if you feel the stinging sensation in the back of your throat, it's a sign of higher than average oleocanthal.
That's
So
a
that's an
great,
interesting fact, I thought. Yeah.
yeah, great distinction there for people to understand. And a lot of people, they'll take an olive oil that is polyphenol rich, and because they're so used to consuming olive oils that don't have the sting or the burn in the back of the throat, they're like, oh wow, that's a strong one, and a lot of people don't like it because, in our society, we kind of like, we don't really like that kind of astringent, pungy kind of bitterness, but that's actually a
Right.
sign of, these polyphenols, these powerful plant compounds that are really supportive to our health.
I agree with you. I find it interesting that in our culture, in Western culture, when I say the word bitter, it has almost negative connotation when it comes to food, right?
Yeah.
But it should really be the opposite. And in other cultures, for example, I traveled a lot in India and I love Indian cuisine. In Indian cuisine, like you desire some bitterness, it's appreciated. You go like, oh, this is bitter, that's bitter, and it's a good thing. It's just one flavor like many others that we should be consuming. And that's nature's signal to us that it's something that we should have. But there are some other molecules that are bitter, and in high dosages they can be poisonous. So I can understand why some
Yeah,
people
for
are
sure.
afraid of that.
For sure.
But oleocanthal, what we knew about it at the beginning was that it killed cancer cells pretty rapidly. We just were not sure how. And that was a really interesting question of the mechanism of it and why is it so specific against cancer cells. And the answer was that we found in my group was quite surprising. Mostly when you study cancer, the first type of result you're looking for is always to see increased apoptosis, right? Because when you have more apoptosis, it's good. Cancer fighting, cancer cells are dying, and many cancers have become resistant to apoptosis. So it's always like this race of how we can, kill just those cancer cells. So what we found out was that oleocanthal doesn't really kill cancer cells via apoptosis, and that's why it can be effective even against tumors that are apoptosis resistant. It kills cells during a different process that's called lysosomal membrane permeabilization. And I know it's a mouthful, but what it basically say, roughly, it kind of pokes holes in the lysosomes in the cells. And that's a bad thing. And cancer cells are more sensitive to that than normal cells. So do we need to explain what lysosomes are?
Yeah. So lysosomes are intracellular organelles that basically break down proteins and different substances within the cell. I know lysosomes play a key role in cellular autophagy for normal healthy cells.
Exactly.
But they're also very, the cancer cell kind of has its own dynamics, right? Its own physiology.
Mm-hmm.
And they use the lysosomes for cellular protection as well. And I'll let you talk a little bit more about why they do that or how they do it.
Exactly. So it's a known fact that double-edged sword of autophagy.
Yeah.
Because autophagy is a natural process by which cells recycle themselves or cells die, and other cells can use their nutrients. But just like we mentioned mTOR, it's a process and a pathway that often cancer hijacks in order to promote growth. So when tumors start, they're very poorly vascularized. They don't get blood supply to the tumor. So how do they get proteins? How do they get nutrients? How do they get amino acids and DNA for growth? Well, they get it from neighboring cells and often via autophagy, which is a process that happens in lysosomes. Mm. So when you damage lysosomes, cancer cells are much more sensitive to that. Okay. Another interesting thing that happens when you damage the lysosomes, the content of the lysosomes spill into the cellular environment. And for the most part, that's very toxic because they're highly acidic organelles. So that kills the cells really fast. And cancer cells just tend to have more lysosomes, larger lysosomes that are more fragile. And we found that Oleocanthal targets and is able to break or permeabilize cancer cell lysosomes much more than healthy cell lysosomes. And that differential effect is how we're able to use it, almost as a drug, right? It's food, but
yeah, powerful. So to summarize that, these lysosomes are critical for cancer growth and development. And the oleocanthal activates lysosome membrane permeability. Is that correct? Is that what you said?
Permeabilization, yeah.
Permeabilization, right? So it makes
it makes the membranes more permeable or punctured.
So they break down. So they're less resilient, right? And they're less so they're more vulnerable to breaking down, less resilient to stress.
Exactly. Yeah. Exactly.
Well, good. Well,
so that was a very interesting result. And then the next thing that we looked at was, if we can achieve those fantastic results, and we saw cell death and a particular cell death using isolated oleocanthal, we asked ourselves the question, how about olive oil itself? People have been using and consuming olive oil for generations, and we always knew it's good for you, it's healthy for you. There's, a million studies that you probably cited before about lower mortality rates and lower cancer rates and lower heart disease, but, why? What's the cause of that? So it was a pretty attractive idea to speculate that perhaps olive oils that have more oleocanthal or have more polyphenols are the reason why olive oil is healthy for us. And we did such an experiment, and we got the result that we expected, which was that olive oils that contained higher oleocanthal were able to kill cancer cells with the same mechanism, with the same dynamics as isolated oleocanthal, actually pretty much with a linear correlation between the amount of oleocanthal in olive oil and its ability to kill cancer cells.
That's powerful. And oleocanthal is also called like plant-based ibuprofen, right? Because it has powerful anti-inflammatory effects.
Correct. Yeah, it's a really strong inhibitors of these two enzymes, COX-1 and COX-2, that sit way up there in the inflammation pathway. So it can reduce inflammations at a cause.
Right. So it's also very preventative for all degenerative health conditions because they're all associated with chronic inflammation. So it really keeps inflammation under control as well, taking it on a regular basis. Now, as I mentioned earlier, most of the olive oil out there that people are consuming does not have much oleocanthals. And so how do we know, like what's a way that that can help us determine, like when we're looking at olive oil, how do we figure out if this one has a lot of polyphenols, a lot of oleocanthal in it?
Right. So just by looking at a bottle, at a label, it's almost impossible, although there are some signs and cheat sheets that I'm sure you're aware of, and I'd like to talk to them about these as well. But the surest sign is to taste the olive oil. Take a spoon or a little shot glass and swirl it in your mouth, swallow it, and see if you feel that stinging sensation in the back of your throat. If you felt that, you can't really tell if it has more or less, but it has more than an average. So it's a good olive oil. It's an extra virgin olive oil. It was stored properly. It's fresh enough. It still has enough oleocanthal. more than the average. That's the only sure sign. But before purchasing the oil, it's a little tricky. Not all companies mention the concentration of oleocanthal, although that's something that they can measure. Everybody can measure that. You can send as a manufacturer, you can send an olive oil to the lab and measure the oleocanthal, and you can publish that. But very, very few companies do that, unfortunately.
Yeah.
So the other way is to understand how is high oleocanthal olive oil made? What are the steps and processes that are really important to make high oleocanthal olive oil, and how it's preserved? So that goes to, of course, we're talking only about extra virgin olive oil and not a lesser grade. And of course, goes without saying that it's cold pressed. But one important thing is the early harvesting of the olives. So if an olive oil, say it's an early harvest, that's usually a good sign, and it usually means that we will find higher levels of polyphenols, because the olives lose polyphenols during the ripening process.
Yeah, green are the most polyphenol rich. So if you're just getting olives, the green ones have more polyphenols. And then as they age, they lose polyphenols and they increase the amount of fat content, oleic acid, which is a healthy fat. They increase fat content, but they lose polyphenols. So the black olives are the ripe ones with more fat, higher fat content, lower polyphenol content.
Correct. And it affects the taste. So the olive oil that's made out of purple or black olives that are more mature and more ripe, it would taste fruitier. It would taste more mild. Some people just prefer that, but they don't have as many polyphenols. For the producers, it's a win-win situation to wait a longer time and produce olive oil from overripe olives, because they get much higher yield. So if you grow your olive trees and you pay for the olives, by weight, you get more olive oil if you wait longer. But the quality of the olive oil is not as good as the ones that are made from unripe green olives. So that would be one thing to look for. Always look for olive oil that's early harvest. The second thing that's really super important is freshness. There is some loss of polyphenols in storage. That loss can be very minimal or very severe depending on storage conditions, and also depending actually on the initial polyphenol concentration, which is a very nuanced point that I can go into. But fresh is always best. In the Northern Hemisphere, olive oil is only harvested once a year during the fall or winter. Again, some producers wait until winter to harvest. In the Southern Hemisphere, Australia and New Zealand, it's produced during their fall, which is our spring. So technically, you can always get olive oil that would be no more than 6 months old. It's kind of possible. Unfortunately, there aren't many oleocanthal high olive oil coming from Australia or New Zealand, I actually don't know about any. I would love to know about some. But olive oil from the Northern Hemisphere, they're made in the fall, and you should really try to consume them within a year. So an olive oil should definitely tell you the harvest date on the bottle or on the box. And you should look for a harvest date that's not much more than a year. I would say 14 months, 15 months, that's fine. We recommend consuming olive oils within the first 2 years of production if they're stored properly. So storage plays a big, big role of that. And if you store olive oil in a heat, the polyphenols would be lost much faster.
Yeah.
If you store it in the cold, that would slow down significantly that loss factor. The other thing that affects the loss of polyphenols during storage is the olive variety and the amount of antioxidative power in it.
Right.
So we mentioned oleocanthal is an anti-inflammatory molecule, but many other polyphenols are antioxidants.
Yeah.
So
and you
if
have
you
vitamin
have
E in there as well. Which is a powerful
in the skin
antioxidant too.
Exactly. So some olive varieties are very, very high in oleocanthal, but are low in other antioxidants. So these type of olive oils might be excellent in the first, 3, 4, 5, 6 months after production, but afterwards they would lose polyphenol and oleocanthal content pretty fast because those molecules tend to oxidize. But if an olive oil is a little more balanced and it has both high oleocanthal and let's say high oleacin, which is a very strong antioxidizer, the loss during storage is very, very minimal, to the tune of maybe 10%.
Now, how about the bottle as well? Because there's a lot of bottles that, are just kind of either clear plastic or clear glass. But I know UV light affects it as well. So what should we be looking for in a bottle?
Correct. Definitely not plastic.
Yeah.
There's been a study that showed that the best material are actually either glass or metal. So metal is okay. Metal tins are absolutely fine. I always thought like, that's probably not a good, but the science is out there. Olive oil sold to you in metal tins is okay. And metal tins are opaque and protect from UV light. But when we talk about glass bottles, always try to look for dark glass, preferably completely coated. There's a lot of glass manufacturers now. You can buy olive oil in blue glass bottles, black glass bottles, white ones that are completely opaque and protected from light. If you see an olive oil in a clear bottle, and if it was on a shelf for a while, it's not great anymore. So some manufacturers sell bottles of olive oil in clear bottle, but they sell it inside a box. That's okay. It was protected from light, but then when you take it home, you better keep it in a closet. Although again, it's that process is not that rapid. If you take an olive oil bottle and you put it in a counter and you use it within 3 or 4 weeks, even if it's clear, you'll be fine. The problem is clear bottles that stand on shelves that has been exposed to light for weeks and weeks at a time. That's not great.
What do you recommend as far as using olive oil? Because there's debate out there. Some people say, hey, you can cook with it. Other people say, probably not the best to cook with. I'm kind of at the point where I think you can cook with it because of the antioxidant content in it. However, you are also sacrificing polyphenols and antioxidants when you do cook with it. So to get the kind of clinical dose for, first, I want to know your thoughts on cooking with it. And then also how do you get the clinical dose that would be effective for, let's say, cancer prevention based on what you guys looked at with the research, if you have a high polyphenol olive oil that you're using?
Right. So, all right. So first question first about cooking. That's actually my favorite myth to bust. And again, I'm just going by published research out there. And there've been a few recent studies that completely busted that myth that olive oil is not suitable for cooking because it might have a lower smoke point than other olive oil. Those studies have proven that there's no correlation between the smoke point. That also is very easy to miscalculate because of water content, and it depends how you measure it. But there's no correlation between smoke point and suitability for cooking. And actually one particular, I believe, Australian study showed that olive oil is the healthiest oil to cook with. And often, maybe I'm already answering one of the other questions, the polyphenols can transfer to the food. They tried it on vegetables. And then they extracted polyphenols from the vegetables that were not there before. So the polyphenols don't just disappear. Some of them do oxidize, but some of them transfer into the food that you cook with. So olive oil is absolutely
and I like marinating too. I'll marinate meat, different things like that I'm cooking with the olive oil, so you get more of that transfer as well. And then the big thing we look at cooking is the oxidative stability as opposed to the smoke point. Olive oil, like you said, olive oil has a high oxidative stability, so it's able to handle the heat because of it's very stable. So that's the key there. Yep. So I'm in agreement on that.
And it doesn't create polar compounds.
Right.
So I think, but absolutely, you would get more benefit from raw olive oil. So let's say you saute with something. I think studies show that it's a function of time and temperature. So let's say, temperature of, I'm trying to calculate Celsius to Fahrenheit, let's say about 250 or 300 Fahrenheit for 20 minutes. Let's say, I think it's in a range of you lost maybe 15 to 20% of the polyphenol content. And the longer you cook or the higher temperature, you might lose more. So you lose some, but there's still a lot. So it depends what you started with. If you started with high phenolic olive oil, it's not a big deal. I think for most people, it really comes down to cost because high phenolic olive oil, it costs more than other oils because you make it early in the season and you get less yield because you have to store it under very, very specific conditions. It costs more to the consumer. So if budget is an issue, I would suggest, using any other affordable, good extra virgin olive oil, depending on your budget for most of your cooking, but then always drizzle the highest phenolic olive oil you can on top. So you get a raw olive oil, or even just take it with a spoon. So as far as dose, I would say, again, depending on polyphenol content. So you could get in the US now, there are quite a few olive oils that are around 1,000 milligrams per kilo polyphenols. That's very, very high. It's definitely in the top 10 percentiles, but there's probably a dozen olive oils available in that range. Of these olive oils, The equivalent of 2 spoons a day is a great dose, both for preventative and
Teaspoons
maybe
or
even
tablespoons?
getting into, sorry, tablespoons.
Yeah, 2 tablespoons a day. Yep. Yep.
2 tablespoons, about 30 grams, yeah, a
Solid.
day. If you're really treating a serious condition and you're able to stomach it and you have room within your calorie intake,
Yeah.
because olive oil is very rich in calories. I definitely don't recommend to like up your calorie intake a lot if that's
Yeah.
wrong for you. So you should be conscious of that. But if you have room in your calorie intake, absolutely. I don't think you can overdo it. 3 spoons, 4 spoons a day, that's fine. I mean, I think I'm 50% olive oil.
Yeah, I love it. Yeah, one of my favorite meals, I'll marinate either salmon, wild caught salmon, or grass fed beef or something like that in olive oil and extra virgin olive oil, high polyphenol olive oil, and then also organic lemon juice, and like put on like garlic, salt, and stuff like that. Some different herbs, oregano, basil, thyme. Cook that, and then I'll make a Mediterranean salad where I've got cucumbers and artichokes and hearts of palm in there, tomatoes. What else? Bell peppers. And then I put the extra virgin olive oil, high polyphenol count, along with some organic lemon juice and a whole bunch of herbs on that salad. And I have olives in there as well, like black olives or green olives.
Yeah.
And
don't forget the nuts.
Yeah,
nuts
a little bit of nuts
and
maybe even some sheep cheese or feta cheese as well in there. And then, yeah, it's so polyphenol rich. So I'm getting the raw. I'm also marinating the meat in it. And I tend to get probably, 3 tablespoons of olive oil in there. But I can consume a lot of calories as well. But that's one of my favorites. I'll usually make a big Mediterranean salad, have it with my dinner, and then have leftovers for lunch the next day. And I usually eat 2 meals a day. So I'm pretty much getting a lot of olive oil, high polyphenol rich olive oil in both of those meals. So it's really good.
And you look great.
Thank you. Well, polyphenols play a role along with the intermittent fasting. So yeah, huge fan of oleocanthal. What are some other polyphenols that you love? I love resveratrol. That's a great one. Quercetin, curcumin. What are some other ones that you love?
To be honest with you, I'm not that familiar with other fruit olive oils. I love blueberries. I know they're very high in their own polyphenols. I couldn't even name which polyphenols. You see, you know better than me. My knowledge is really about olive oil polyphenols.
Yes.
But yeah, I mean, they exist in skins of many fruits. So, fruits, vegetables, I mean, that should be the main part of our diet, right?
Yeah, absolutely. So how much olive oil, how much high polyphenolic olive oil are you consuming on a daily basis?
I think I'm averaging about 5 tablespoons.
Nice. You're getting it in. There you go. Yeah. Awesome. And the company you created here, obviously, you found all this amazing research, but then when you went out and you looked at the olive oils that were on the market, you just found that they were failing people, right? They just didn't have the high polyphenolic compounds in them. And so you started Kyoord, which is Kyoord. You guys can go to kyoord.com, right? And so what is Kyoord?
It's actually, well, it's pronounced cured.
Cured. Okay. So kind of like cured.
Or it's a cure for something.
Right.
I can't claim it, but we know it. So I couldn't call the company, you will be cured.
You found a unique way to spell cured that wouldn't draw attention from the FDA or, any of the governing bodies.
Hopefully.
Yeah. So guys, check it out. kyoord.com. You guys can use the coupon code Jockers to save 20% off too, to try it out on your first bottle. So you could try it out. And this is an amazing olive oil. This is an olive oil that I've used as well. I love it. Definitely has the oleocanthals. You get that little bitter aftertaste. And what are some of your favorite recipes that you use your olive oil in?
I love to pre-make sauces and marinades and dressing with the olive oil. So I make a great aioli. You take an egg yolk, a little bit of mustard, a little bit of red wine vinegar, and about a cup of olive oil, and you emulsify it. It's like a mayonnaise or something like that, but it's healthy. It's made of 100% olive oil. Right. No canola there. I love making chimichurri. I grow a lot of herbs in my garden, And as you mentioned, actually, some herbs are also a great source of polyphenols, especially I think oregano.
Oh yeah, oregano.
So I make a tincture
Carvacrol.
with
Carvacrol is one of the main ones that's in oregano.
Mhm.
Yeah, I love it.
Yeah, it has a beautiful molecular structure, I remember. So I use parsley, mint, oregano. I use about 50% parsley, 25% mint, 25% oregano. I throw in garlic, ginger, a lot of red pepper flakes, red wine vinegar, and olive oil. And I make a chimichurri that goes great on any kind of vegetables, on a sandwich, or on steak.
That sounds great. Yeah, you're getting me hungry over here. The Mediterranean diet, I mean, it really does work. And one of the reasons is these polyphenols, probably one of the main reasons. And it tastes good as well, right? When you start combining herbs like that, very, very flavorful. And also those herbs, they release and they have an aromatic compound to them, a smell that you will notice throughout the house. And that smell itself will actually activate your vagus nerve, and it will activate your digestive juices. So you start producing stomach acid, bile, pancreatic enzymes before you start your meal, which is really good because that helps kind of warm up, prepare your digestive system to be able to break down and assimilate the nutrients more effectively with the least amount of stress on your body when you do consume your meals. So getting in those aromatic compounds is so powerful. So love it. Dr. Goren, any last words of inspiration or anything we didn't cover that you would like to share with our audience here?
Yeah, I mean, again, talking a little bit about, I understand that cost is an issue for a lot of people. And I think it's one of those things that we've been accustomed to getting cheap but inferior products for many years. And sometimes investing in your health and wellness is not really an expense, it's an investment, right? So that's something to keep in mind. And then combine it with the other best practice for health, which is free, which is exercise. Don't forget to exercise, and that's always free.
Yeah, we're huge on that. And so, guys, yeah, we didn't even talk about how a lot of the olive oils out there aren't even fully olive oil. A lot of times they're like 50% olive oil, 50% canola oil, corn oil, all these toxic industrial oils. So a lot of people are using olive oil that's actually destructive, actually causing a lot more free radicals, a lot more inflammation in their body. You want to make sure you're getting a really good quality extra virgin olive oil, particularly, if you really want the best health benefits, a polyphenol rich extra virgin olive oil. You're going to pay a little bit more for it, but think about it almost like medicine. Really, that should be the way that we're looking at food is as medicine. And we always want food that has the maximal amount of powerful nutrients in it and the least amount of toxins. And that's what you're going to get when you check out kyoord.com, KYOORD.com, some of the best olive oil that you can possibly find. Use the coupon code Jockers at checkout to save 20% off. Dr. Goren, thanks so much for your time. Really enjoyed the conversation. And guys, we'll see you on a future podcast. Be blessed, everybody.